Welcome back, geometry students. Today we're doing some virtual learning on 3.4, which is parallel and perpendicular lines. We're not doing the triangles, that's for 3.5. Let's go ahead and jump right into it. This is just real simple here. This section is talking about different properties of perpendicular parallel lines and how they relate to each other. It's kind of following the rules of logic. So this first one is kind of like a syllogism one, or the transitive property. Here we have three lines, as you can see here, 1, 2, 3. And we're asked, well not asked, but we're proposed this little conjecture. If L is parallel to M and M is parallel to N, okay, so as you can see here, L is parallel to M, M is parallel to N, then what can we say? Well, we can say, let me change colors, something a little bit brighter. L is parallel to N. Okay, this is following the transitive property, kind of like syllogism. So the conclusion of one becomes the hypothesis of the other. Essentially what happens is this M connects these two, and you can remove the M, and therefore you just have the L is parallel to N. And you can clearly see that in the diagram as well, that L is going to be parallel to N. Next up, we have parallel lines from a transversal theorem. This is a little bit different. We say if M is perpendicular to T and N is perpendicular to T, okay, so we have two lines perpendicular to the same one, then what can we say? Okay, so M perpendicular to T, N perpendicular to T, what can we say? What profound statement can we make? And that is that M and N are parallel to each other. So if they're both hitting a certain line, in this case it would be a transversal labeled T. If it's both hitting the same line at the same angle, then it must be that those two lines are parallel. So we're going to say M is parallel to N. Okay, that's our second one. Moving on to the third and final one, the perpendicular transversal theorem. If M is perpendicular to T and M is parallel to N, then what can we say? What profound statement can we make? So we know that these two lines are parallel to each other. We know T, this little transversal, is hitting at 90 degrees. Okay? It's almost like we have the corresponding angles property going on here. We know that N will also be perpendicular to T. So N will also be perpendicular. Okay? So that's just kind of like using some logic and reasoning. We can figure out angles just by using some of these theorems and logic that we learned earlier. That's all we have, those three. But stay tuned for next time we talk about 3.5 parallel lines and triangles. This is a good one. Stay tuned.